Hey guys! So today we're going to start the day 6 video, and tomorrow we're basically going to be working on the same thing. So if you get confused by our worksheet tomorrow, you can just, on day 7, you can just come back and rewatch the video. Alright, so we're going to be talking about percentage composition of a compound. This is a little bit different from what we've been working on before, because right now we're not going to be calculating moles or any of that. Basically what we need to do is find molar masses of compounds and find out what percentage by mass of each compound does each element in that compound have. And to further clarify that, let's go ahead and look at this image. So if I was looking at a compound like iron 2 oxide, Fe2O3, I can see that if I take that compound and I weigh each part of it, about 70% of the compound is going to be made up of iron, and about 30% of that compound is going to be made up of oxygen, which means that 30% of it is oxygen's percentage composition, right? So basically what we're going to be doing, take a compound and find out how heavy each element in that compound is and how much they weigh in the compound. What is their percentage composition of the compound? And if you see that these numbers in total, 69.9 plus 30.1, will total up to 100%. So throughout these examples, you are always trying to get a total answer of 100%. It's not always going to be perfect. Sometimes you'll get 99.9%, but that's close enough. Now, if I look at a different element, like iron 2 oxide, this is clearly a very different ratio. Here it was 2 to 3, here it was 1 to 1. Now, some of you may think, why is it not a 50-50 split down here, right? Well, the truth is, if you look at the periodic table and you look at their molar masses, oxygen has a lighter weight than iron. So even if I had 1 iron to 1 oxygen, it is never going to be a 50-50 split because oxygen is lighter than iron. So normally naturally, it has a lower percentage composition in the overall compound because it's lighter, right? And again, all of this equals up to 100%. There may be some cases where they don't, and in those cases that means that there is an element missing, but we're not going to be going over examples like that. So just in general, all your numbers by the end of your examples should equal up to 100%. So let's go ahead and try this example. This is copper 1 sulfide. So you guys know that you need to use the periodic table to find all of these examples, or to find all of the molar masses, right? All right, so let's go ahead and get started. If I look at my periodic table, I know that copper has a mass of 63.55 grams per mole, and sulfur has a molar mass of 32.07 grams per mole, right? So before I start, I need to find the molar mass of the entire compound altogether, all right? So the molar mass of Cu2S is equal to 2 times the molar mass of copper, which is 63.55, plus 32.07, which is the molar mass of sulfur. My overall molar mass of the entire compound will end up being 159.17 grams per mole. All right? Now, this is obviously not the end of the question because we're trying to find out what is the percentage composition by mass of copper and of sulfur in the compound. So I should end up getting an answer that is in percentage, right? All right, so now I need to find the molar mass, or the mass overall of copper in my compound. This is very simple. So for Cu, I know that I have 2 coppers, so all I need to do is this. 2 times 63.55. And that ends up equaling to 127.1 grams per mole, right? So This means that in my compound, 127.1 grams of the compound come from copper. All right? And MS for sulfur is just 32.07 grams per mole. So out of my entire compound, 32.07 grams belong to sulfur and 127.1 grams belong to copper. Okay? Now, finding the percentage composition is extremely easy. All you have to do is divide it by the total number and multiply it by 100 to find the percentage composition. So let's say this is the percentage of copper. What I'm going to do is I'm going to take the number 127.1 and divide it by 159.17 times 100%. So as you guys can see, the 159 came from here and the 127 came from here. So this is the mass of copper and this is the total overall molar mass of the whole compound. All right, so now let's go ahead and calculate that up. It ends up being about 79.85%. So the 79.85% of this entire compound is made up of copper. Now let's find out how much of the compound is made up of sulfur. So percentage of sulfur is equal to the molar mass of sulfur divided by the total molar mass of the compound. I'm just going to go ahead and erase this just so that nobody gets confused, and multiply it by 100%. And my overall percentage composition of sulfur is going to end up being 20.14% of my whole compound. So this looks good. I was able to find that about 20% is sulfur and about 80% is copper. Now let's double check to make sure that we've done everything right. The easiest way to check is to just add all the numbers together and make sure that they equal up to 100. That equals up to about 99.99%, which is extremely close. And remember, that 0.01% was probably lost due to rounding errors, which is not a huge deal. You could even end up getting 99.98%. That is also totally fine. All right? Nobody's perfect, and you really can't always get perfect results. All right, so let's try another example here. Barium fluoride. So, if you look in your periodic table, you'll be able to find the masses of barium and the molar masses of fluorine, right? Okay, so first of all, let's find the molar mass of the overall thing all together. It ends up equaling to the molar mass of barium, which is 137.33, plus 2 times the molar mass of fluorine, which is 19 grams per mole. And in total, they end up being 175.33 grams per mole. All right? So this is my overall molar mass of my compound. So now let's find my molar mass of barium. This is simple because there's only one barium. All we need to do is take it right out of the periodic table. No need to multiply it by anything. And then fluorine. Oops. For this one, we will need to multiply the fluorine by 2 because there are 2 fluorine atoms, so we have to account for that in our question. So 2 times 19 is equal to about 38 grams per mole. Now let's find the percentage composition of barium and fluorine in barium fluoride. So percentage of barium in our compound is 137.33 divided by 175.33 times 100% equals to about 78.32%. All right? And then my percentage of fluorine is equal to 38 grams per mole divided by 175.33 times 100% is about 21.67%. So I can see that of barium fluoride, about 22% of it comes from fluorine and about 78% of it comes from barium. So now let's go ahead and double check to make sure that our numbers all equal up to 100. So 78.32% plus 21.67%. All that equals up to, not 100%. Again, we are at 99.9. Remember, it's never really going to be perfect, because that's life. All right, so you guys get the basic idea. Now we're going to go into one that is a little bit different, but honestly, it's not harder. In fact, it's kind of easier. So in this question, we need to find the percentage composition of water in sodium carbonate decahydrate, all right? So in some compounds, water can attach to the compound and form a hydrate, all right? So if you ever see the word hydrate, that means that there is a water molecule attached to the compound. And when you see decahydrate, you guys remember mono, di, tri, nona, blah, 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 blah. Deca means 10. This means that overall, my compound has 10 water molecules that are bound to it, all right? So this is actually a lot easier than what you would think. We have already been given the molar mass of the whole compound, so that really makes our job a lot easier. Now all we need to do is find the overall mass of water in our compound, which is very simple. All right, so the molar mass of H2O is equal to 2 times 1.01. If you guys are wondering what this is the molar mass of hydrogen, plus 16, which is the molar mass of oxygen, equals to about 18.02 grams per mole. Okay, good, but we have 10 water molecules, so we need to multiply this by 10 to end up getting 180.2 grams per mole. So that is the total mass of water in our overall compound. Now let's go ahead and calculate what percentage of the overall compound is made up of water. So percentage of H2O in the compound is equal to 180.2 divided by 286.19 times 100% is equal to about 62.96%. All right? So this basically tells us that about 63% of this whole compound's weight comes from water. So if I took this compound and I dried it up, it would lose a whole bunch of weight from that, right? And the remaining weight that is in the compound comes from the rest of this sodium carbonate, all right? So now guys, you're gonna go ahead and work on your worksheet and give it a try. And again, for tomorrow's lesson, we're gonna be doing the same basic thing. So you could just come back, rewatch this video if you're confused.